Hello class, this will be the final part of the video where we'll be looking at weighted graphs and the shortest path problem. In this video, we're going to be looking at a second example of how to find the shortest path using Dijkstra's algorithm. So in this second example, we're going to be using Dijkstra's algorithm to find the shortest path between vertex A to vertex F. So again, we'll just start off by setting up our table and we'll put our starting vertex as the first row and we'll put up all of the other vertices in the columns. To complete the row, we record the distance connected between each of the vertices. So going from A to B, that has a distance of 2, A to C has a distance of 6, and because there's no edge connecting from A to D to E or to F, we just put a cross in between. Now that we've completed the first row, we need to look for the smallest number and draw a box around it. In this case, the smallest number is 2, so I want to draw a box around it. And because the number 2 belongs in column B, that's going to be our next row. And now we can start to fill up all of the other values in this particular row. Again, what we do is, because it's a box number, I'm just going to copy the box number below and go from B to C. That has a value of 2 plus the 2 that I've traveled. So therefore, it's going to be 4 in this case. And because that's smaller than 6, I'm going to put 4 down below. To go from B to D, that's going to add another 3. So 2 plus 3 in this case is going to be 5. Because there's no 5 in that, I'm going to put 5 in that cell down below. To go from B to E, I want to add another 2. So 2 plus 2 in this case is going to be 4. And because there's no direct edge going from B to F, I want to put a cross. After I've completed this row, I'm going to look for the next smallest unboxed number. In this case, I could either go with C or E. It doesn't actually matter which vertex you're going to go with, but in this example, I'm going to go with vertex C. So vertex C in this case is going to therefore be the next row in the table. So now I'm just going to copy down the next box numbers into that row. And now to fill out C to D, that is going to have a distance of 1. So 1 plus 4 in this case is going to be 5. And because that number is identical to that number above, I'm just going to keep that same number. To go from C to E, there's actually no edge at all. But what I'm going to do is I'm just going to copy down the number above that on the table. So I'm going to put 4 down below. And to go from C to F, there's no edge. And so therefore, I'm going to put a cross. Now that I've completed this row, I'll look for the next smallest unboxed number. And that's going to correspond to vertex E. So now vertex E is going to be the next row on the table. And I'm just going to copy again the box numbers down below and fill out columns D to F. To go from E to D, that's going to be a distance of 2. So therefore, 4 plus an extra 2 is going to be 6. But because that number is smaller than 5, I'm going to copy 5 down instead. And going from E to F is going to add an extra 3. So 4 plus 3 in this case is going to be 7. The smallest number in this case over here is going to be 5. So that's going to be my next box number. And therefore, D is going to be my next row. Similarly, I'm just going to copy the box numbers down below. And going from D to F is going to be 5 plus 5, which is 10. But because that number is smaller than 7, I'm going to copy 7 down instead. Now that I've done everything and I've completed my Dijkstra's table, I can therefore find out what is the shortest path in this particular network. So again, I'm going to start from this value over here. And I'm going to go up until I see the last 7 in that column. The last 7 is over here. So I'm going to draw a vertical line going up to here. And that corresponds to row E. So now I'm going to draw a horizontal line until I reach column E. So therefore, that's what it will look like. And what I'm going to do now is just repeat the same steps. So in this case, because that number corresponds to the number 4, I'm going to draw a vertical line until the last 4 I see. The last 4 that I see in that particular column is over here. So I'm going to draw a vertical line going up to here. And that now corresponds to row B. So I'm going to draw a horizontal line from row B to column B. So therefore, in this case, it will stop there. And again, I'm just going to go up until I see the last 2. And then finally stop where it has row A. Now that I've done this, I'm just going to analyze it. So the horizontal lines in the table indicates the shortest path taken. So in this case over here, the horizontal lines are where row A, B, and E are. So ultimately, my answer is going to be starting at A, going to B, and then to E, and finally to our destination vertex, which is going to be F. By now, you should be a bit more confident at using Dijkstra's algorithm to find the shortest path in a network. What I'd like you to do now is I'd like you to please answer the remaining questions from exercise 14D to get more practice. This is the end of the video. Thank you guys for watching, and I'll see you guys again in the next one. Bye.